July 17, 1981, Kansas City, Missouri. The Hyatt Regency Hotel.
It was supposed to be a celebration, a tea dance. 1,600 people packed into the atrium lobby.
The architecture was modern. Open space, 3 suspended walkways floating above the crowd.
The second floor, the third floor, and the fourth floor, steel and concrete bridges connecting the north and south wings.
At 7:05 p.m., the band started playing Satin Doll. The lobby was wall-to-wall people.
People were dancing on the walkways too. Roughly 40 people on the second floor, maybe 20 on the fourth.
The fourth-floor walkway was suspended directly above the second-floor walkway.
They were hanging by steel rods, just thin metal lines, holding up tons of concrete.
Suddenly, a loud crack echoed through the atrium, sharp like a gunshot.
Witnesses looked up. They saw the fourth-floor walkway drop a few inches. Just a glitch.
Gravity took over. The connection failed. The fourth floor smashed down onto the second floor.
Then both walkways, now a combined mass of debris, fell 40 feet to the lobby floor.
64 tons of material, hitting the ground in less than 4 seconds.
It wasn't just concrete. It was steel, glass, and human bodies.
The impact severed the hotel's main water pipes. The sprinkler system blew out.
The lobby started flooding. Survivors were trapped under the rubble, drowning in inches of water.
The dust cloud was massive. Visibility dropped to 0. The silence was instant. Then the screaming started.
First responders arrived, but they couldn't move the debris. The slabs were too heavy.
They had to bring in heavy construction cranes. They were breaking through the front glass windows just to get equipment inside.
Chainsaws, jackhammers, oxyacetylene torches. The lobby turned into a triage center.
The rescue operation lasted 14 hours. It was a slow, grinding nightmare.
By morning, the count was horrific. 114 dead.
216 injured. Some with limbs crushed, others with internal bleeding.
It remains the deadliest non-deliberate structural failure in United States history.
Initially, everyone thought it was resonance. Too many people dancing in step.
Or they thought the materials were cheap, substandard concrete, weak steel.
But the physics didn't add up. The load on the walkways was way below the safety limit.
The walkways were designed to hold much more weight than they were carrying that night.
So why did the steel snap? Why did the rods pull through the beams?
We aren't looking for a bomb. We aren't looking for sabotage.
We are looking for a design change. A subtle alteration in the blueprints.
A change that happened months before the hotel even opened. A conversation between an engineer and a fabricator.
They changed how the rods connected. They turned a long rod into 2 short ones.
And that decision, made to save a few dollars on assembly, cost $140 million in lawsuits.
We need to dissect the connection. The box beam, the nut, the washer.
We need to understand how a simple phone call can kill 100 people.
The devil is in the details. In this case, the devil was in the connection point.
Let's open the file. The Hyatt Regency walkway collapse.
Time to look at the mechanics of a massacre. To understand why this happened, you have to look at the free body diagram of the hanger rods. The original design called for a single, continuous steel rod running 45 feet from the ceiling, passing through the 4th floor box beam and continuing down to the 2nd floor. In this configuration, the nut under the 4th floor beam was only supporting the weight of the 4th floor walkway. The weight of the 2nd floor was carried by the rod itself, bypassing the 4th floor entirely and transferring the load directly to the ceiling. It was a redundant, safe system, where each connection point only had to manage its own local load.
But that design was a logistical nightmare for the fabricators at Haven Steel. Threading a 45-foot steel rod is incredibly difficult, expensive, and prone to damage during transport. The construction schedule was on a fast-track system, meaning they were building the hotel while the designs were still being finalized. The fabricator looked at the blueprints and proposed a value engineering change to simplify the assembly. They suggested cutting the long rod into 2 separate pieces, one rod connecting the ceiling to the 4th floor, and a second, offset rod connecting the 4th floor down to the 2nd.
That change fundamentally altered the physics of the entire structure, and nobody on the engineering team caught it. By offsetting the rods, they changed the load path completely. Now the second-floor walkway wasn't hanging from the ceiling anymore. It was hanging directly off the fourth-floor beam. The fourth-floor connection point now had to support the weight of the fourth-floor walkway plus the entire weight of the second-floor walkway hanging below it. Effectively, they doubled the load on the fourth-floor box beam connection without adding any reinforcement to handle the extra stress.
This fatal proposal was handled over a simple phone call. The fabricator called the project engineer, described the change as a minor detail to facilitate erection, and the engineer approved it verbally. There were no new calculations performed. There was no updated sketch sent for review. The revised drawings were eventually stamped approved, but the engineer of record later admitted he never actually checked the connection details. He assumed the fabricator had run the numbers. The fabricator assumed the engineer had checked the design. It was a circle of negligence driven by the pressure to open the hotel on time.
The component that failed wasn't the steel rod, it was the box beam itself. These beams were made by welding two C-channel steel strips toe-to-toe, creating a hollow rectangular tube. The problem is that hollow tubes are weak when you pull on them from the center without a stiffener. With the load doubled to nearly 21,000 pounds per connection, the washer and nut didn't snap. They pulled right through the steel. The bottom flanges of the box beam curled upward, deforming like soft clay, until the nut slipped through the gap, releasing the second floor and dragging the fourth floor down with it.
The financial implications of this oversight were staggering, but the human cost of the fast-track philosophy is what defines this case. The project was plagued by communication breakdowns from day one. Documents were lost, change orders were informal, and the chain of command was blurry. This wasn't a material failure, the steel was fine. This was a management failure. They saved a few $1,000s on easier rod assembly, but the resulting collapse triggered billions in insurance claims, legal settlements, and the bankruptcy of the engineering firm involved. The legal fallout was absolute and devastating for the engineering firm, GCE International. The Missouri Board of Architects, professional engineers, and land surveyors conducted a massive investigation, ultimately charging the engineers of record with gross negligence, misconduct, and unprofessional conduct. The defense argued that it was standard practice for fabricators to design connections, but the board rejected that entirely. They ruled that the engineer of record has a non-delegable duty to the public safety. You cannot outsource the responsibility for the structural integrity of a building to a subcontractor or a fabricator. As a result, the two lead engineers on the project were stripped of their licenses in Missouri, and eventually in essentially every other state where they practiced. It sent a shockwave through the industry. If you stamp the drawing, you own the failure.
This disaster fundamentally rewrote the rulebook for structural engineering and construction management across the United States. Before the Hyatt, the review of shop drawings, the detailed fabrication blueprints made by contractors, was often treated as a casual, rubber stamp process. After the collapse, the American Society of Civil Engineers, ASCE, mandated rigorous peer review protocols. Now, for complex structures, there is a requirement for a structural observer who actually walks the site to verify that the connections match the calculations. The concept of redundancy became a religion. You never design a critical load-bearing connection where a single point of failure results in a total, progressive collapse. Without a backup load path,
The fast-track construction method, where construction begins before the design is fully finished to save money on inflation and financing, was put on trial. While it is still used today, the Hyatt Regency stands as the grim monument to its dangers. The investigation revealed that the design team was so overwhelmed by the accelerated schedule and the constant stream of change orders that they simply stopped checking the details. They were saving time on the schedule, but they were accruing a technical debt that was paid in human lives. The final settlement of $140 million was the largest of its kind at the time, but it highlighted a terrifying economic reality. The cost of safety protocols is a fraction of the cost of catastrophe.
From a survival and tactical perspective, this event is terrifying because there was zero warning and zero cover. In most structural failures, you get auditory cues: creaking, popping rivets, drywall cracking, minutes or hours before the drop. Here, the failure mode was brittle and instantaneous. The box beam deformed and the nuts slipped through in milliseconds. The only takeaway for the operator is situational awareness regarding crowd density on suspended structures. If you are on a balcony, a skywalk, or a temporary viewing platform, and you feel a rhythmic bounce or see visible deflection under a heavy crowd, you evacuate immediately. Structures have limits, and crowd loading is dynamic and unpredictable.
The legacy of the Hyatt Regency is that every engineering student in the world now studies this case in their ethics class. It serves as a permanent reminder that a calculation is not just a number on a page. It is a representation of real forces acting on real people. The engineers didn't wake up that morning wanting to kill anyone, but their complacency and their refusal to recheck a minor change created a weapon out of a walkway. The verdict is clear. In the world of heavy industry, assumptions are fatal. You either know the load path or you don't.
Gravity is the one constant that never negotiates, never sleeps, and never forgives a mistake. It doesn't care about your deadlines, your budget, or your misunderstandings with the fabricator. The moment you lose respect for the physics will bury you. Check your connections, verify your loads, and never assume someone else did the math. Stay sharp.